So we will continue with the golden ratio. So we have this word problem determining golden measurements. And it reads, web page designers sometimes incorporate the golden ratio into their layouts. These dimensions make the site easy to navigate. Suppose a web page designer designs a layout for an iPad that is 1024 pixels wide. The designer would like the home page divided into 3 columns in which each column is progressively wider than the previous column using the golden ratio. How wide should the designer make each column? So let's just point out a couple of things. You should always read a word problem twice so that you're clear on what's being asked. And you should always draw a graphic or doodle somehow. It helps lend some clarity. But certainly let me point out a couple of things. We're going to be using the golden ratio. Each column, there's going to be 3 columns. We have it right here, 3 columns, and each column is going to get progressively wider using the golden ratio. And the overall width of the 3 columns is going to be 1024 pixels. So I'm just going to go ahead and draw an iPad here, what I think it would look like. You should always do this too. Kind of helps you visualize what's going on. And it doesn't have to be anything perfect, as long as it gives you an idea. So if this is the top of or the face of my iPad, the designer wants to create 3 columns. So I'm just going to kind of pen them in here. And each column gets progressively larger according to the golden ratio. So this whole thing here, this whole iPad here is going to be 1024. And we need to determine the width of each one of these columns. That's what the word problem is saying. So I certainly don't know how wide this column is going to be, but I do know how wide it should be in relation to this column and how wide this one should be in relation to this column. And I certainly know that the whole thing's got to be 1024. So I'm just going to label this as X, or any variable is fine, but X is usually the standard. So if this is X wide, then I'm just going to multiply this by phi, which is the golden ratio. We know that to be 1.618034, and it's going to give me the width of this column. So I'll just put it in as phi times X. Then we have this column, and the width of this column, multiply this column by phi. What is this column? Phi times X. So I'm going to have phi times X. Don't forget that phi times phi, anything multiplied to itself, we can square it. So this can be written as phi squared. But all I know that if I go ahead and I add up this column to this column to this column, it's going to come out to be, or should come out to be, 1024. So we'll do that. So we have X plus phi times X plus phi squared. I'm going to write it as phi squared X. And that should equal to 1024. So I have X plus phi. What's phi? 1.618034X plus phi squared X. Phi squared is 1.618034 squared, and that just happens to come out to be 2.618034X. And that's got to equal to 1024 pixels. So now all we have to do is gather up like terms. X plus 1.618034X plus 2.618034X is 5.236068X. And that's all got to equal to 1024. Using some algebra, we'll go ahead and we'll divide out the 5.236068 from either side. These values will cancel. That's the whole idea. That's why we do it, leaving us with X. So then x has got to be equal to 1024 divided by 5.236068. That's going to come out to be approximately, and we're just going to round this to 2 decimals, 195.57 pixels wide. So this first column here should be 195.57 pixels wide. This next column should be this first column times phi. So I take 195.57 times 1.618034, and this should be 316.44 pixels wide. And then this should be this column times phi, and that comes out to be 512. And of course, if we add up 195.57, add that to 316.44, add that to 512, and it's going to come out to be 1024 pixels. And I think we have it.